Hi everyone, this is Dr. GVR Seshagiri Rao, Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So we are discussing about engineering tribology subject. So already we have studied briefly about the friction, wear and lubrication and corrosion and the engineering materials. So in this engineering tribology, the selection of material is very important to avoid wear or friction or corrosion. So today I want to discuss some definitions and terminology, the important definitions and terminology related to these engineering materials. So in this, the first one is define soap or alloys. So sometimes in examination they will ask like this, the definition, how do you define the soap or alloys? The soap or alloys are heat resisting alloys based on nickel iron or cobalt that exhibit a combination of mechanical strength and resistance to surface degradation. These materials, alloys, are called soap alloys. So, what are the applications of soap alloys? Soap alloys are primarily used in gas turbines, coal conversion plants, and chemical process industries, and for other specialized applications requiring heat or corrosion resistance. So, what are the nickel based soap alloys? The nickel based alloys are materials that are composed mainly of nickel and some other alloys. So, the nickel based alloys are known for their excellent corrosion resistance and strength. They are often found in high temperature environments due to their superior resistance to heat. So, in this case, in nickel based alloys, the base metal is nickel and other elements added to this base metal to enhance the property of the material. So, what are the properties of nickel based alloys? The nickel and nickel alloys are non-ferrous metals. These are not ferrous, with high strength and toughness and excellent corrosion resistance and superior elevated temperature properties. Pure nickel is a bright silver white metallic element of the iron group and is hard, malleable and ductile. So these are the properties of nickel based alloys. So why is nickel based in alloys? Nickel alloys are used extensively because of their corrosion resistance. So why? Because these materials are used extensively. The high temperature strength and their special magnetic and thermal expansion properties. So widely used due to these reasons. So what are magnesium alloys? So this magnesium alloy is also similar to the nickel based alloys. In this, the base metal is magnesium and other metals included added to this magnesium alloy to enhance the properties of the material. These alloys are mixtures of magnesium, the lightest structural metal, with other metals called an alloy, often aluminum, zinc, manganese, silicon, copper, rare earths, and zirconium. The magnesium alloys have a hexagonal lattice structure, which affects the fundamental properties of these alloys. So, list out various types of magnesium alloys. The magnesium alloys can be categorized into two groups. One is cast alloys and wrought alloys. The cast alloys are basically made by pouring the molten liquid metal into a mold within which it solidifies into the required shape. Wrought alloys, on the other hand, are alloys subjected to mechanical working such as forging, extrusion, and rolling operations to reach the desired shape. These all are mechanical machining process, manufacturing process, forging, extrusion, and rolling. What are the physical properties of magnesium alloys? The magnesium alloys are materials of interest mostly due to their high strength to weight ratio, exceptional machinability, and low cost. Than other reason. They have a low specific gravity. How much? Having 1.74 gram per centimeter cube. And a relatively low Young's modulus. So that is 42 gigapascal. Compared to other common alloys such as aluminum or steel. They suffer, however, from brittleness and poor formability at room temperature. Their formability increases with increasing temperature, but that requires high energy. So these are the main physical properties of magnesium alloys. Let's define the applications of magnesium alloys. The magnesium alloys cover a wide array of applications from automotive and aerospace applications to electronic and biomedical uses. Structural applications, electronic applications, and medical applications. What is medical, structural applications, and electronic applications? These magnesium alloys are widely used. Next, what are titanium alloys? Titanium alloys are alloys that contain a mixture of titanium and other chemical elements, such as alloys have a very high tensile strength and toughness. The tensile strength and toughness, ductility, and malleability, these are all mechanical properties. So even at extreme temperatures, the toughness having these alloys, they are light in weight, have extraordinary corrosion resistance, and the ability to withstand extreme temperatures. So that is the main reason it withstand extreme temperatures. So what are the types of titanium alloys? The titanium exists in two crystallographic forms: at room temperature, unalloyed, commercially pure. The unalloyed means, and titanium has a hexagonal close packed, that is HCP, crystal structure referred to as alpha phase. When the temperature of pure titanium reaches 885 degrees centigrade, the crystal structure changes to a BCC. HCP to BCC structure known as beta phase. So, what are the applications of titanium alloys? Due to the high specific strength, a good fatigue resistance, and a creep life, and good fracture toughness are characteristics that make titanium a preferred metal for aerospace applications. It can withstand high temperatures and good fatigue resistance. So fatigue is very, very important in the mechanical properties and mechanical components. So this whenever the component, the machine component is subjected to repeated loads, the cyclic loads. So there the fatigue failure will be occurred due to the yield strength. So this type of phenomenon is called as fatigue. But this titanium alloy is having that resistance, fatigue resistance. So whatever, how many times you are applied, uh, so no problem. It will consider and no fatigue will be happen. The aerospace applications including use in both structural. The structural is airframe components and jet engines still account for the largest share of titanium alloys. So that's why these titanium alloys are very preferable in the aerospace industry. Next one is ceramics. Ceramics are typically hard and chemically non-reactive, can be formed or densified with heat. Ceramics are more than pottery and dishes. Clay, bricks, tiles, glass, and cement are probably the best known examples for these ceramics. So generally, the pottery and dishes items made with these ceramics. Which the applications of ceramics? The ceramics are also used to make objects as diverse as spark plugs, fiber optics, artificial joints, space shuttle tiles, cooktops, race car brakes, and micro positioners, chemical sensors, self lubricating bearings, and body armor and skis. So these are the applications of ceramics. The fiber optics and artificial joints and race car brakes, so made with this ceramics. Next material is define the term polymer. So how do you define the polymer and then classification and properties we will see. A polymer is a substance or material consisting of very large molecules called macromolecules composed of many repeating subunits due to their broad spectrum of properties. Both synthetic and natural polymers play essential and ubiquitous roles in everyday life. Polymers range from familiar synthetic plastics such as polystyrene and to natural biopolymers such as DNA and proteins that are fundamental to biological structure and function. So, what are the types of polymers? The polymers are two types: naturally occurring and synthetic or man made. Either it may be naturally occurring or synthetic and are man made. The natural one is the natural polymeric material such as hemp, shellac, amber, wool, silk, and natural rubber have been used for centuries. A variety of other natural polymers exist, such as cellulose, which is the main constituent of wood and paper, the cellulose. So these are the types of polymers. The synthetic is the list of synthetic polymers roughly in order to worldwide demand includes polyethylene, polypropylene, polystyrene, polyvinyl chloride, synthetic rubber, phenol formaldehyde resin, that is our backlight, neoprene, nylon, polyacrylamide, PVB, silicon, and many more. So these are the types of polymers. So widely used this polyethylene and polypropylene, and this formaldehyde resin, phenol formaldehyde resin, so known as bakelite, are used in electrical items. Example: the switches made with this bakelite, nylon, so silicon, and many more materials. So define polymerization. This polymerization is the process of combining many small molecules known as monomers into a covalently bonded chain or network. During the polymerization process, some chemical groups may be lost from each monomer. This happens in the polymerization of PET polyester. So define polymer morphology. The polymer morphology generally describes the arrangements and microscale ordering of polymer chains in space. The macroscopic physical properties of a polymer are related to the interactions between the polymer chains. So next one is, what are polymers applications? So nowadays the synthetic polymers are used in almost all walks of life. The modern society would look very different without them. The spreading of polymer use in connected to their unique properties, low density, and the low cost, and good thermal or electrical insulation properties, high resistance to corrosion, and low energy demanding polymer manufacture, and facile processing into final products. So these are the main applications of polymers. That's why nowadays it is commonly used material in our daily life. So these are the references I have taken for this definition terminology related to engineering materials. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.